Okay, the definition of the composition of two functions. Well, basically the composition of the function f with the function g is, and you would say this, f of g. This is called f of g, which basically means you're going to take the g problem, get an answer, and then plug it in the f one. So the domain of f of g is a set of x in the domain of g, such that g of x is in the domain of f. Fancy way of saying, do g first, then plug it into the f function. Alright? And of course it's read f of g is read as f of g. That basically is the word of. Alright? So, forming the composition of f with g means this. Find f of g for f of x, the square root of x, provided x is greater than or equal to 0, because that would be the domain. And the same thing right here, g of x when x is greater than or equal to 0. So first off, if possible, find f of g of 2, which means this. Notice, this means do the g function first. You're going to do the f function last. It's kind of like you have to do the closest things first and then you move backwards. So I'm going to plug, in a sense, the x minus 1 function. G of x is x minus 1, and I'm going to plug it into that function. So there's what we have. We have the square root of that there, and this is only true when x is what? Greater than or equal to 1, because we have to have positive values in there. So now to evaluate it, f of g of 2, I do 2 minus 1. I can plug it in the equation we got right here, and I get the square root of 1, which is 1. And now I'm going to do the other one. I'm going to plug the g function in this one we just made. 0 minus 1 is negative 1, which is not possible or defined. Now, I could also have done this. I could have put this 2 in here, which is really what happened. 2 minus 1 is what? 1, and then put that in there, which is really what happened right here. 2 minus 1, there it's exactly the same thing. So, but what you do is on the f of g, you do the last one first and take that answer and put it in the other equation.